Alright, sorry about that. So in that last video, we were talking about this waveguide design problem where we wanted an air-filled circular waveguide such that only the dominant mode will propagate over a bandwidth of 10 gigahertz. So the first thing we did is we found the cutoff frequency for the dominant TE11 mode, and then we found the cutoff frequency for TM01, which would be the next higher mode. So these were the two formulas that gave those two frequencies, and then the PowerPoint basically just cut off, not no pun intended, just cut off right then and there. So these are the two formulas that we ended that last video with. And so now to come in and plug in some numbers, when you plug in some numbers, you basically get the following: that you have the difference between the higher order and the lower order, and then you have to set that equal to 10 gigahertz because that's the bandwidth that you want to propagate. So you want 10 gigahertz bandwidth, um, and you want to know what the cavity dimension would be. You want to know what the radius would be. So you plug in the speed of light, you plug in the 2 pi, and you solve for A, and then you find that A would be 0.269 centimeters. So now if you plug 0.269 in to calculate the cutoff frequency of the TE11 mode, you find that you get 32.7 gigahertz. And if you set it equal to, if you plug it in for the TM01, you find 42.76 gigahertz. So if you take the difference here, you would have a 10 gigahertz bandwidth that could be propagated in that circular waveguide before you would pick up the next higher order mode, which was the point of